So, isotopes are atoms of the same element therefore they have the same number of protons but with a different number of neutrons. Different number of neutrons. So, one example could be, we'll do chlorine. You can have 37 and chlorine 35. This will have 17 protons, 17 protons. But the neutrons now is 37 minus 17 equals 20 neutrons. This one is 35 minus 17, 18 neutrons. So, different number of neutrons. Okay, so isotopes, atoms of the same element. So by the same element, by definition, that means they've got the same number of protons, okay? But they've got a different number of neutrons. So two examples would be the chlorine example, chlorine 35 and chlorine 37. They both got 17 protons, but as you can see here, chlorine 37's got 20 neutrons, chlorine 35 has got 18 neutrons. So different number of neutrons, therefore they are isotopes of each other. Another example, this time got 3 isotopes. This is for magnesium. Magnesium's got an atomic number of 12, but it may have 12 neutrons, 13 neutrons, or 14 neutrons, depending on which isotope we are dealing with. Again, different number of neutrons, same number of protons, these are isotopes. If an element was going to the airport, going through customs, and it was asked for its ID, it would present its atomic number, okay? Because its atomic number is what identifies it as a specific element. So in the case of chlorine, it would show its ID to show it's got an atomic number of 17, okay? Its mass number, 37 in some cases. Some chlorine's got 37, some have got 35, so that can be different. But to show its chlorine, it would have to have an atomic number of 17. If it's not 17, it's not chlorine. It's not getting in. For magnesium, its atomic number would have to be 12, okay? As we can see, it's got different numbers of neutrons in different cases. Again, different mass numbers. But what makes magnesium magnesium, and therefore magnificent, is its atomic number of 12. 12 protons only, therefore your magnesium